You know, when we think about finding aliens, we've always been told to look for a world that's, well, just like ours. In this explainer, we're going to show you why that might just be the single biggest mistake we're making in our search for life beyond Earth.
It's the question, right? The one that's captivated us for forever. We point our telescopes to the stars. We search for those planets in the Goldilocks zone. You know the one, not too hot, not too cold, just right for life as we know it. But what if that whole idea is, well, just a bit short-sighted? What if we're so focused on finding a comfortable, Earth-like home that we're missing the bigger picture? What if the real key to finding life out there isn't about finding a perfect copy of our world, but about understanding the absolute toughest, most resilient life forms that exist right here on this one? So let's meet the organisms that are basically tearing up the biology rulebook and rewriting it from scratch. They're called extremophiles. And they don't just put up with extreme conditions. They absolutely thrive in them. And that right there is the most important part. That word, extreme, it's completely our own bias. For these little microbes, a boiling hot spring full of acid, or the insane pressure at the bottom of the ocean, that's not extreme. That's just home. So, just how tough are these things, really? Well, by studying them, scientists are figuring out the absolute outer limits of where life can survive. And some of these numbers, wow, they're going to blow your mind. All right, first up, let's tackle temperature. We usually think life needs a pretty cozy, narrow range to get by, right? Well, maybe think again. Now get this, the record holder for heat, Methanopyrus candeleri, it doesn't just survive at 122 degrees Celsius, which is way, way above boiling. It actually grows there. And on the flip side, you've got Planococcus halocreophilus, just chillin' and growing at a frosty minus 15 degrees. Okay, so it's not just about temperature. Life has also figured out how to master some really extreme chemistry. Let's look at the next challenge, pH. You know, the scale for how acidic or alkaline something is. These numbers are they're completely nuts. Picrophilus oshimai is chilling at a pH of negative 0.06. That's more acidic than the acid in a car battery. And then you have Serpentinamonas thriving at a pH of 12.5, which is basically like drain cleaner. And somehow they manage to keep the inside of their cells at a normal, neutral pH. It's just an unbelievable bit of biological engineering. So life can handle the heat, the cold, and the crazy chemistry. But what about just pure physical force? The kind you'd find at the bottom of the Mariana Trench. Yeah, life's conquered that too. The champion here, Thermococcus piezophilus, can handle 125 megapascals of pressure. Now, to put that into perspective for you, that's over 1,200 times the air pressure we're feeling right now. It would be like balancing a whole skyscraper on a tiny little postage stamp. And it just keeps on going. All right, from crushing pressure, let's move to another really basic challenge for life, water, or more specifically, the lack of usable water. See, if you have too much salt, it just sucks the water right out of your cells. So the ocean is salty, right? It's about 3.5% salt. But this organism, Halosynactobacter silvermanii, lives in water that's 35% salt. That is 10 times saltier than the ocean. It's an environment that would dehydrate and kill pretty much any other living thing on the planet instantly. Okay, so life can take extreme heat, acid, pressure, and salt. But now we get to the one that feels the most, well, alien of all, radiation. It's a constant threat in space and on any planet that doesn't have a nice, thick atmosphere and magnetic field like we do. And you know, while we tend to think of radiation as a problem for astronauts, the truth is, life on Earth has been getting zapped by it for billions of years, from our sun and from deep, deep space. The real problem with radiation isn't about getting warmed up. It's about surviving this constant storm of high-energy particles that literally shred DNA to pieces. To deal with this, some bacteria have evolved these incredible, super-fast DNA repair kits that let them withstand radiation doses thousands of times stronger than what would be fatal for a human. So, what does all of this mean for the hunt for aliens? Well, it means we might have been looking in all the wrong places. Knowing what life can actually put up with right here on Earth completely changes the game. Just take a look at Jupiter's moon Europa. For a long time, we thought its hidden ocean would be way too extreme for life.
But look at this comparison. The pressures, the temperatures, the likely saltiness, it's all well within the known comfort zones for the extremophiles we find in our own oceans. In fact, for some of these microbes, Europa would actually be a pretty nice place to live. And once you start thinking that way, it's revolutionary. Suddenly, the list of possible homes for life in our own solar system just explodes. We're now seriously talking about the acidic clouds of Venus, or salty water hidden deep under the surface of Mars, or the oceans under the ice of moons like Enceladus and Titan. What this all boils down to is that these tiny, tough-as-nails survivors have forced us to just throw out our old, narrow definition of a habitable zone. The actual boundaries for where life can exist are so much wider and so much weirder than we ever imagined.
Which brings us to a totally new and I think much more exciting question. It's not really just about whether there's life beyond Earth anymore.
The real question now is, how many worlds did we write off as dead and barren just because they don't look like our own backyard? The universe might be absolutely teeming with life. It just might not be in the places or in the ways we've been taught to look.